Hi, my name is Matin Lotfali and this is the demo of improving fingertip tracking using genetic programming. This demo is followed by the paper after it, which is fingertip tracking with Kinect on the left side, and it was written by Mr. Abraham Hashemian and Matin Lotfali 2 years ago, and we tried to improve the tracking accuracy using genetic programming as a thesis of bachelor of my university. So, as you know, we try to detect the fingertip location using Microsoft Kinect depth view, and we change the coordinates and we try to locate it on where it is on the monitor. As you can see on my monitor right now, but it has some problems. As you can see, I want to show you the problem. When we detect each frame, the fingertip is moving so fast, and it is not accurate, it is not reliable, but it is so fast, which means if I move my finger to any side, it moves fast. We tried to solve this problem using a variable called smooth factor, which is written in red in upside, which means we try to actually have an average of frames, so the fingertip will get much more much more smoother. So if I increase the value of smooth factor like this, if I add the smooth factor 7, 8, 9, 10, if I change it to 20, you can see that the vibration is stopped, and actually it is now much more smooth. But here comes another problem, which is when I move my finger fast, it takes around 1 second or 2 to reach to my finger. So that's the problem, that we cannot use the simple average as a solution for making this tracking accurate. So if we want to actually conclude the problem, you can see here, if the smooth factor is 1, when my finger is stopped, it is so unstable, but it is moving so much fast. But if the smooth factor comes to 20, it is when my fingertip is actually stopped, it is much more stable. But when I move my finger, it becomes so slow. It comes with so much delay. But what do we want? We want both of them. I need my fingertip tracking to be stable when my finger is stopped. But I want when my finger is moving, I want it to be fast. So the smooth factor should change. Should change to 20 when my fingertip is stopped, and change to 1 when my fingertip actually is moving. Alright. So we tried to have a solution using genetic programming. We used random equations as chromosomes, 10 crossovers, 4 mutations, and to reach an equation that could give us the smooth factor number. As a result, we reached best of them is as I can show you, exponential cosinus hyperbolic speed minus 2 as the best one that we actually reached as a solution using this genetic program, which I will give you in a paper, so you can have the details of what we have done. And we had also other equations which were not so much efficient, like exponential, cosinus, hyperbolic. If I want to show you how it works, as you can see, when my finger is stopped, the smooth factor goes to 20, 30, sometimes 50. But when I move my finger, it decreases. It becomes 5, 10, 6. If I move my finger much slower, it becomes 15, 10. But if I won't move it fast, it remains lower than 10. So it means that it worked great. So I can use this result for my presentation. I can use it in actually for gestures. I can use it as an alternative for the mouse of computer. We also tried to test other equations, like detecting if my finger is moving or not, and have a smooth factor, which is also described in the paper. Actually, the difference is when I move my finger slowly, it remains to 1, but if I keep it actually stopped, it goes to 15. But when I move it slow, it starts from 1, and that is not a good thing. So it shows that as a result, exponential, cosinus, hyperbolic is an efficient equation for this problem. We also tried to experiment these equations and actually determine the errors that we have, and we try to have other equations using acceleration, because we had some problems in acceleration of fingertip moving, which is our future researchers in this area. Thank you for watching.